so here we have, hey there, welcome back. Here we have this graph here. And if I wanted to look at what its inverse is, remember your inverse is a reflection over the line y is equal to x. So if I wanted to know what this inverse was, I can look at it and pretend like I have reflected it or switched it over that line. All right, so let's take these one at a time. If this is f of x, an input of negative 4, 1, 2, 3, 4, leaves me an output of positive 1, 2, 3. An input of negative 1 gives me an output that is equal to 0. Now check this out. This is my inverse. So with my inverse, remember my x and y tables are switched. So an inverse that has an input of negative 5, I'm actually going to look on the y's for that. 1, 2, 3, 4, 5, and figure out where my x input was, which is 1, 2, 3. So this is how we denote inverse, and this is how we want to make sure that we're talking about those input-output tables switched. Now, if it's easier for you to think about these input-output values, negative 4 goes in, 3 comes out, negative 1 goes in, 0 comes out. If I had a 3 go in, 1, 2, 3, negative 1, 2, 3, 4, 5 would come out. When I'm asking about the inverse, that's where I switch the x's and y's. All right, so if I want to know the inverse of an input of negative 1, that's like when negative 1 comes out of the function, so that's going to be positive 1. So if I want to have an inverse input of 0, that means where is there an output of 0, and that's at negative 1. An inverse value of 3, 1, 2, 3, except I want an output of 3. 1, 2, 3, and that'll be this point here, negative 1, 2, 3, 4. And notice these two share that relationship. An input of negative 4 gives you an output of 3. The inverse's input of 3 gives you an output of negative 4. These also work as inverses. All right. When we find the inverse of each equation, we're going to swap x and y and then solve for my new variable. So I'm going to say x is equal to negative 2 times y minus 3. And now I need to solve for y, meaning get y by itself on one side of the equal sign. So I'm going to add 3 to each side. And then, of course, divide by negative 2. So my y inverse is equal to negative x over 2 minus 3 halves. Okay, sorry about this one. So swap x and y. So x goes here, and y goes here. And now I need to solve for this y. So it looks like I'm going to multiply each side by y. And then divide each side by x. Okay. Here we are here. So we want to go ahead and swap our x's and y's. So we'll put our x here is equal to negative y cubed plus 3. Then we'll go ahead and solve for this y. So x minus 3 is equal to negative y cubed. We're going to divide by negative 1. So I wind up with, we'll come up here, y cubed is equal to the opposite of x plus 3. And then, of course, to get y by itself, we have to then take the cube root. So I have y is equal to the cube root of the opposite of x plus 3. All right, my next one, again, I'm going to swap x and y. This is like my y. So I'm going to say x is equal to 2y minus 1 over 3. Multiply it side by 3. 3x is equal to 2y minus 1. Add 1 to each side, and we'll come up here. 3x plus 1 is equal to 2y. Divide by 2. So my y is equal to 3x plus 1, all divide by 2. All right, so here's the thing. If f and g are inverse functions, then the compositions of each other work out to solving to just plain x. So we can remind ourselves what the fog and the golf means, f of g of x and g of f of x, and that's our composition. So here we have our two equations here, okay? And we can test to see, are they inverses? And if they are, then we should get x when we put them into composition. So if I talk about g of x, and then I take f of g of x, what I'm talking about is putting g into f. So that's going to be equal to, here's my g function, and I'm putting him into my f. Here's 2x minus 5. There he is, in for that x, plus 5 over 2. So when I have 2x minus 5 plus 5 all over 2, here I have a zero pair. So I wind up with 2x over 2. And then I wind up with simplifying those and just plain old x. So far, so good. All right, now let's test the other way. We can say that g of f of x should also be equal to x. So this was where it was equal to x, and here it was, so it checks. Let's try it over here. So I'm going to put what I know for f in for g. So g is 2 times an x value minus 5. And I'm going to go ahead and put f in, x plus 5 over 2. Now check it out. This 2 over 1 is going to cancel, and I'll get x plus 5 minus 5, which guess what? Is equal to x. So yes, these are inverses of each other, because when I do a composition, I get x. All right, you try this one and tell me what you think. How'd you do? Mine did not work out. So it was close, and I went back and checked my math over and over again. But when I distributed this 3, and I got 3 over 3x, which is 1x, and this is going to be minus 3 plus 2, that didn't work out. And then I came down here, and I have 1/3 here, and I ended up with a positive 2/3. So again, that didn't work out. All right, so inverses, feeling good.